Hey everyone, Grant here. So we're back after a few months of not posting. We still love you, don't worry. I think we all just had a few other things we needed to prioritize in the last couple of months. In the episodes moving forward, we're going to start branching out a lot more in the type of topics that we discuss, many of which will include things that we're not at all experts in. You'll see what I mean by that in the next few months as episodes get published. So in this one, the discussion was centered all around color and color vision. And before I start, I should say, if you actually want to learn about color vision in a really beautifully presented, deep way, there's an absolutely fantastic blog post by Jamie Wong. I'll link to it in the description. I highly encourage you to check it out and take the time. All right, I just wanted to make sure that shout out was in here. So without further ado, let's dive right in.
Okay, did you guys hear about the dress?
Of course. I barely follow the news, and I mean barely. And even I would say that you'd have to be living under a rock on Mars not to be familiar with the dress.
For all the Martians that didn't hear about this, and I didn't know the details. I knew about it. I knew that basically my knowledge going into looking up what happened with the dress was somehow there was a picture on social media and people disagreed about the color of the dress and it turned into a big hubbubaloo. I didn't know anything about where the picture originated, who disagreed in what way, for what reasons did they disagree, any of that sort of thing. Does that describe you?
But you saw it, at some point, right?
I saw the picture and I was like, oh, that's on social media. That's the thing everyone's arguing about.
And you came to an opinion, I assume, as soon as you saw it, or did you have some information beforehand?
Black and blue.
Okay. But you just looked at it and you're like, oh, it's obviously blue.
Totally. You guys?
Yeah, for me, I was actually in the office and someone had come across it and had it on his screen, and he'd called a number of people over to look at it. And so I had the pleasure of encountering this in a group of people who, as it turned out, did not all agree on what color it was. So that was a lot of fun.
Well, first of all, let's all just establish our teams here. Where are you, Eater?
Oh, it's obviously blue.
This is a shame. We all agree it's obviously blue.
Oh, that's such a shame.
No, but it's funny that you bring up being in a group of people. I feel like in the same way everyone remembers where they were on historically meaningful events, right? I can't think of a one that feels more positive than this, but we all know where we were on 9/11. And I feel like in a very similar way, we all know where we were when we first saw the dress, especially if it was with a group of people. Because I was in such a group, and there were, I think, 2 people who saw it as white and gold and were very insistent. And I remember having the 100% sincere thought that, and this was a sort of communal house situation that I was in, that an email had gone out to a couple of people that they were going to collaboratively troll half of the household, right? And they would pull up an image and just insist that it was a different color than it was to see if it would drive us crazy. Right?
So you didn't see any way that it could possibly be interpreted that way?
Yeah, this was the level of how I was feeling. It was more conceivable to me that there was this conspiracy to troll us than it was that the dress was white and gold.
Wow.
It was only when I saw the XKCD, showing it in different lights, and then a couple other explanations that came out after that showing in different lights, that I had the feeling of, kind of. And even then, I feel like a lot of people would see the versions where you have dimmer lights or more overexposure on one half, and then they'd be able to say, okay, I can kind of see why the middle dress would go either way. And I would still find myself in this position of, if you change the lights, I can see it. But when I look at the original image, I just really can't do it.
So I'm looking at it right now. I agree it's clearly blue, and it seems preposterous to think otherwise. There's something weird about the blue, though. The light shines off of it in a way that makes it kind of an unordinary image.
Yeah, I guess I can kind of see that.
So, okay, so I dive into the dress. Did you guys know the background? So I think the background's fascinating. It's the classic situation. Mom's going to the daughter's wedding. She can't figure out what dress to wear. Innocently takes a picture of the dress, sends it to her daughter. Kind of a family drama ensues about the color of the dress. And
wait a minute, I have to interrupt you because I just looked up the dress. I typed the dress into Google and I clicked on the Wikipedia link and I'm looking at the picture and it is white and gold.
What?
To you?
To me, right now.
No. So you're a flopper.
I'm a flopper, I guess. I'm like starting to wonder, like, is someone trolling me with Wikipedia? Did they like tone it down a little bit, or this is bizarre?
Well, I'll tell you, it is as blue and black as it's ever been to me.
Let me refresh. Nope, still. Oh, this is weird.
So in one of the studies that they link to on Wikipedia, they've got 10% of people are capable of switching between color combinations. So they actually did a scientific study of this, and I guess you're 1/10 that can switch depending on I don't know what.
Oh, interesting. So it's like that rotating naked lady illusion.
I'm not sure I know that one.
Oh man, this is all great podcast fodder, strongly visual. Okay, look up like rotating lady illusion or something to that effect. It's essentially one of these things where if you were to show it to a group of people, half of them would say that she's rotating clockwise, half would say that she's rotating counterclockwise.
Gotcha.
And you could probably get the same fierce argumentation that you have over the dress if you posed it correctly. But that one, I find it much easier to switch if you kind of close your eyes and do the right imagining, then open them again. And it's this really bizarre feeling to see one thing, know on a conscious level that nothing has changed in the physical world and it's only in your mind, and yet have this very visceral feeling that there's been this just multiply by -1, totally turning in the other direction.
I'm watching this woman. I'm really trying to get to switch right now.
To you, which way is she rotating?
Did she just switch? I don't even know how to define it. As she's facing me, she's going from her left to right, clockwise.
Clockwise. Interesting.
Yeah, that's what I'm seeing.
Oh, I got it.
Struggling to get it to switch.
Oh, she's rewinding the clock.
Isn't it bizarre though? It's like this truly, I don't want to call it like a surreal experience, but it's one of those that does a really good job making you understand the difference between the world as it is and the world how you perceive it.
Yeah. So what I thought was fascinating is kind of the way different people picked up on it. I thought was kind of emblematic of, I don't know, where we're at or something. So first you have social media going nuts. And then you have the media and like BuzzFeed first, but followed on by CNN, followed on by Fox News, followed on by literally every media company is trying to get on this because it's, I mean, blowing up the internet. Absolutely. And then you have scientists actually publishing in peer-reviewed journals discussing it as well. And this is exactly the way I guess if you were going to transition, you would expect, right? Social media to scientists, kind of answering different questions in different ways. And I thought that was really, really interesting to dive into.
It's like the opposite way that like normal research goes.
Yeah.
That's funny. Yeah. We learn about our color perception in an incomplete reverse from how we learn about gravity waves.
Yeah, that's a really interesting point.
So, I mean, did you look into a scientific explanation at all? Like, why is this pattern of colors prone to such a strong illusion?
So I read, and the Wikipedia links to a variety of different journals that I kind of dove around into. I could never really get a good, simple, concise explanation as to what was happening. I think one scientist explained it as the illusion was caused by a strong yellow light shining onto the dress. That some other people disagreed with. Like it just, nothing ever felt really great to me. And then the paper that I actually dove into, I cannot believe they did this. They took 1,400 people and 1,400 might be high, but they took some number of people and they put them in an fMRI machine while they looked at the dress. Like, no kidding.
This is
like weird.
I had no idea what sort of follow-on research happened here.
Like Science Direct, Cortex, like a bunch of German neurologists and neurophysiologists in 2015 published this peer-reviewed article analyzing the differences in brain activity while viewing the dress, and then they come up with kind of differences in means and other statistics based on who saw what.
So from the limited reading that I did about color perception prior to this podcast, I actually think I could offer, I'm sure they came to some more sophisticated conclusion, but I can give a little insight on maybe why why blue and gold in particular are more prone to this kind of illusion than another pair of colors you might come up with.
Mm-hmm.
So, I mean, there's like two phenomena happening here. So the simpler one is just how if you were to look at like a white sheet of paper and then you were to be shining a pink light on it or a blue light on it or a green light on it, cognitively, you still perceive the thing as white. It's not like you're saying, oh, that piece of paper suddenly turned green before my eyes. You think, no, it's a white piece of paper and the ambient light around me is just green. So our brain does a really good job. Oh, there's actually a specific word for this, color constancy, where basically we are aware that ambient light can change the literal wavelengths hitting our retina, but that doesn't change our subjective experience for its color. And another thing going on here is how the way that we perceive colors kind of comes in these opposite pairs. And this is really well illustrated if you Google right now inverted color flag, and this might actually be fun to do. So Google inverted color flag.
All right.
So do you see a picture of like the American flag or maybe a UK flag where the upper left corner of it, where there are the stars, the backdrop is all yellow and the stripes are like sort of teal. And all right, so this is the kind of thing that it will take like a minute or two and we'll like edit that out just for constancy. But I want you to spend the following 60 seconds staring just at a single point of that flag as intently as you can. And just stare at that single point for 60 seconds. I realize I should have made sure that there was like a white wall somewhere near you or something white that you'll be able to look at after, but keep staring intently at that one point. All right, so it's probably been enough time. So if there's a white wall near you, turn and look at that white wall and then maybe like blink a little bit if you need to.
Oh, yeah. Wow.
Done correctly. What you should see is that the after image of this flag is an American flag with all of the correct colors.
That's
what
bonkers.
Yeah. Yeah, vividly correct colors.
Right. So that's crazy, isn't it?
Yeah.
So I think this is a super good illustration of one of the theories for how color vision works, called, I think, the Haring Theory, where colors will come in these pairs. So green and magenta are opposites, blue and yellow are opposites. You might notice how sometimes you can mix colors together and it makes sense to talk about, say, like a yellowish green or a bluish red. But if you think about it, if you try to imagine a bluish yellow or a greenish magenta, those sort of don't make sense. It makes as much sense as talking about a slightly positive negative number. So something clearly in our perception, and this, I'll just flat out say, I don't really understand. Something makes it so that our subjective experience comes in these opposing pairs. And maybe it's just if one particular neuron is firing, then that is a component of blue in what we're seeing. And if it's not, that's a component of yellow, whatever it might be. But as far as the dress is concerned, the fact that the blue and yellow come in these pairs does make it kind of seem reasonable that whether you see something as like the fundamental backdrop is an ambient yellow light, and it's the main color of the dress is blue with the non-colored portion in that ambient light being black, or if the ambient light in the background is more of a bluish, and that means that the actual dominant color of the dress is the like opposite thing standing out, the sort of yellowish, the gold, whereas the non-colored portion that's just picking up on what the ambient light is with that color constancy phenomenon is what your brain thinks of as white, in the same way that if you shine a blue light on a white sheet of paper, your brain still thinks of it as a white sheet of paper. Like that would be my like very loose understanding of why this dress, as opposed to some other pair of colors, has this illusion. I would be curious, actually. I bet we could test this with something where you could have people debating over whether something is, I don't know, it would be like black and green versus red and white. We could probably contrive something with another pair of opposing colors like that. I wonder if people have done that, actually.
Like sense the dress, you're saying?
Yeah, I want to design a new dress where it brings up these same debates, but it's not like half of the people are saying it's black and blue, half are saying it's white and gold. Instead, make it so that half the people are saying that it's red and black, and half of them are saying that it's white and green. You know, I think you could construct that dress.
So what's interesting to me on a related note is in reading a couple of these articles written about this, it's as if we accidentally stumbled on something that we sort of knew maybe could possibly exist, but never like so vividly could someone imagine an image kind of splitting the human population down the middle so well. And the way that was contrived was not by scientists picking specific hues off of the color wheel. It was by like an accidental blowing up of social media. And certainly different images like this, or maybe like situations or something like have popped up in the history of the world. But like like they were only seen by a few people, and there were probably some like frivolous debate between a mother and a daughter, and then they moved on and like had coffee and a tuna sandwich. But this didn't, and now we're like just fascinated by it. But it's so weird to me that this was the way in which this sort of phenomenon came to be.
Yeah, it's almost like that. It's so difficult for such a phenomenon to be produced that it took, you know, the entire world using the internet for as long as it did to produce one picture.
Yeah.
Because you would imagine like that hypothetical debate between the mother and the daughter of this picture in this day and age, that would just be put online. It'd be like, well, we don't agree, so let's throw this up on the internet and see what everyone else thinks. And one of us is going to be right and one of us is going to be wrong, and that's that.
Yeah, but instead we have this.
We have one instance of that, maybe two if you want to get into the tennis ball.
True. I wonder how many more we're going to have.
I don't know about the tennis ball.
So this.
What do I Google?
I don't know how big this is necessarily.
Before you Google anything, what color is a tennis ball?
Yeah. Actually, yeah. Stenhouse, what color is a tennis ball?
It's yellow.
Fascinating. I always would have said green.
I also would have said green.
Am I trying to Google something right now?
It's I don't actually know if there's a Googleable thing, because I don't think this was certainly nowhere near as big as the dress. Basically, this was brought up on a different podcast between YouTubers, or really I guess it was brought up when one of them like tweeted it, where he was just asking his wife like, what color is a tennis ball? And it was another one of these, what was a casual domestic debate just was put online in the form of a Twitter poll and then turned into a much larger debate among internet communities. And it was picked up on a couple of like main news sites. I think the height of it was that someone was shouting at Roger Federer in a crowd like, hey, Roger, what color is a tennis ball?
Oh, that's a good bit.
Isn't it? Yeah.
That's a great bit.
But at this point, any listener of Hello Internet is like, why am I listening to this? I've just listened to the exact same retrospection about the sequence of events on another medium.
So, okay, so I have one question here, and then we can move on to one other thought on the dress, which is, with the tennis ball, I think I answered yellow from a social construct. Like, I thought, in the same way I would tell you a fire truck is red, even if, without thinking about that. I just said yellow because I feel like society somehow like implicitly told me that the tennis balls are yellow, and that's the correct answer to that.
I think that's how I got to green. Was it's just like, well, tennis balls are green.
Really? So are we hitting on like a cultural construct then?
I don't know. So for me, I saw the Twitter poll and I was like, well, it's green, obviously. And then I happen to have a tennis ball in my room here. And so I looked at that and I was like, well, I guess I could see how you'd be confused, but it's still green, right? And I answered green and I saw the poll was about 50-50. And I was like, huh. And then I looked online and determined that the answer was probably supposed to be yellow.
Weird. Back to take home the dress, and we can end on this, end the dress conversation on this if we want. But one article really just I found to be really, really interesting. So the fMRI article that I was telling you guys about, they take these people, they put them in, they scan them as they're looking. And what they find is that the white gold people have higher activation in the places in your brain that are responsible for like higher order thinking.
Really?
And it's very significant. I'm having trouble with the numbers looking now, but every single one of them had like higher activation than the average for the blue and black group. And then you go on to speculate, like, what does that mean that this is in some way indicative of like intelligence or cognitive ability in some way or something?
Half of the listeners right now are like, you bet it does. It absolutely does.
Exactly. It's so fascinating. And
so as soon as you said that, I was starting to wonder because it had flipped for me, right? And I was like,
oh, get out of here.
If I'm doing more cognitive, higher order cognitive thinking now than I was 3 years ago. But then, get this, I scrolled up looking at Wikipedia and it's blue again.
No.
I couldn't make this up. This is ridiculous.
You're a switcher for sure.
Well, what we're witnessing is how able you are from moment to moment to think on high order, intelligent, abstract levels.
And apparently that has been going down since we started podcasting.
Yeah, we've been intellectually exhausting you here or something. You need to eat a little more glucose and suddenly you'll be back up there again.
This is so weird.
To get into educational assessment, this is maybe a little bit of a stretch, but go with me here, boys. So we have, and we're very okay with it, we have standardized tests that we assess children on. They assess skills in a particular domain, or they can just assess raw intelligence and IQ and cognitive capacity. And so we have that and we're okay with that. And then researchers kind of lately, and I don't know to the degree to which we want to or should dive into it on this podcast. But there's kind of a debate of, well, we can look at genes and maybe say something about intelligence as well. And some people are like, oh, that's okay to do in these certain circumstances. And other people are like, that's the most ridiculous, absurd idea ever. Don't do that. That's going to lead down a really wrong, bad path. And I kind of had this dichotomy in my mind. But now what we have is like sort of a third thing in the middle ground, which is something which is maybe like correlated with the genes. It's not like a traditional assessment item, but you could think of this as like another way to kind of judge intelligence in some way. That's somewhere in the middle between a standard assessment item and just actually looking at your DNA and breaking down your genes.
Interesting. Well, so implicit in you saying that, you seem to be thinking that the difference between how people see the dress is genetic.
Yes, that's in my mind for sure.
See, I don't know if I'd agree with that.
I definitely don't agree with that because I'm pretty sure I haven't changed my genes in the last 10, 20 minutes.
well, I mean, but let's say, is the reason you're a switcher that you have that ability to switch genetic?
Yeah. You could have a genetic predisposition to switching for sure. So how would it not be? I've made no sort of conscious, or you think it's like some environmental thing throughout my childhood, like led me to this path of seeing blue?
I do. Well, okay. So what is utterly mysterious to me is how we distinguish which colors we see. This is not immediately related to the dress, right? Like what I draw is the line between like yellow and green, right? At what point do I stop calling something yellow or start calling it green? Or why is it that we chose to distinguish the colors between, wavelengths of like 450 and 700 as red, orange, yellow, green, blue, purple? Could it be the case that like a different culture would have divided that instead of into 6 colors into 8 or into only 5? Like I have 2 open questions. One, is that objective or subjective, right? If you played over history many more times, would we still come to the same divisions of the rainbow into red, orange, yellow, green, blue, purple? And then whichever way that goes, like what determines it if it is subjective? And then if it's objective, like what determines that? What is defining the line between red and orange? It seems that there's at least a component of it that is subjective because there are different cultures that divide up colors in different ways. And I think, there's one anecdotal situation that I'm skeptical of, but I have heard is that, and I'd actually love for someone to confirm or deny this. In the language Russian, you have separate words for what we would call light blue and dark blue as separate from our words for green and blue. And supposedly this makes the subjective experiences of, say, looking at a sky versus looking at a deep ocean seem just like separate colors, as separate as, looking at a green leaf is from looking at a blue ocean. And if that's true, right, if the language that we use can make it so that we divide something different in that way, then I could absolutely see there being similar nurture-based factors that make it so that when you're looking at a dress, do you typically think of the world as having like an ambient yellowish light, and you're confirming that when you look at the picture, or do you typically think of it with more of an ambient bluish light, and that's what's confirmed as you're looking at this image?
So I feel you. To draw the comparison to IQ, I'm not sure if this is so different, right? Like no one thinks that IQ is 100% genetically determined. It's determined by sort of the nutrition you had growing up, the experiences you've had to some degree, right? Like this seems like it falls into that same category in that same way almost.
When you're saying genetic, you're using it in a much broader, like genetically influenced things that are perhaps dominated by the experience that someone has growing up after that. But the genetics is what determines kind of how they fall from one way to the next when there's an ambiguous experience.
Yeah, or within a group that has similar cultural experiences. Like it would be surprising to me if the reason why Eater sees it different than I do is because of something sort of cultural or something about his past versus mine.
Well, it could be environmental, right? It could be the case that depending on the sorts of spaces that you hang out in or have hung out in recently, the lighting might be different. If you spend a lot of time indoors and it's fluorescent, then it's one sort of color temperature is kind of your normal that you're calibrated to. Whereas if you spend time outside, that's different. Or if you spend time inside and it's incandescent light, then that's different.
Man, I would love to see studies on that actually, because I could imagine a correlation between the kind of people who spend more time indoors at desk jobs and like quote unquote higher order thinking versus those who like spend time outside, much more thinking about not higher order stuff, but physical things in the world. And like I wonder if it's a false correlation that we're looking at with the higher order thinking.
So you're saying that, yeah, the correlation between higher order thinking and seeing the white dress is actually the fact that where you spend your time correlates both with higher order thinking and with how you see the dress.
Yeah. I don't want to place a sense of judgment on when we say the word higher order thinking. I would not at all correlate that with intelligence. I think those are separate things. But whether or not you tend to be thinking in very general circumstances, like if you're a software engineer, like the kind of things that you're thinking about are meant to apply in a plurality of instances. But then if you're doing something, I don't know, even if it's just like, what's a good, what do people do outside? Sports, I guess. if you spend your time like,
when was the last time you were outside, Grant?
Who are you? I'll have you know, just this afternoon I decided to do some writing outside just by like storyboarding a thing without a computer, and it was lovely. But
I'm glad you. I'm just kidding.
But it did have a feeling of being much more like of the world rather than trying to put things out. I don't know. You kind of see what I'm saying, right?
I like understand what you're saying. I'm unsure what to do with the conversation at this point.
Yeah, let me maybe try to tie a couple things together. So one thing you were kind of talking about, Grant, is asking about to what degree is our subjective experience of color related to the culture that we're in or the environment that we're brought up in versus how much of that is just sort of built into us, and why is it that, we divide the color spectrum up into the different colors that we divide it up into. And perhaps there is, some biological, well, I assume there is some biological component to that, which is that, your eye is made up of these different sensors that sense different wavelengths. And then I wonder, though, that if there's variation in that. So, for example, maybe, you have different cones on your retina that detect different wavelengths. And so maybe, I have a cone that detects 700 nanometers. But maybe because of some genetic variation, your cone detects, better at 702 nanometers. It's a slight difference, but the sort of difference you'd expect with genetic variation. And so maybe, some of those slight variations do crop up, and that might have something to do with the discrepancy that people have around the dress or things like that, for various reasons that maybe we don't understand, fall into an interesting valley between different things. But that in general, like there is this biological way that we detect different colors, and because of that, we couldn't just have some culture that conceives of completely different colors, in the way that you were suggesting, that perhaps in if you grow up speaking Russian, you see blue and green, or you see two different shades of blue as totally different colors.
So let me tell you about a misconception that I realized I had about color perception. This doesn't refute anything that you're saying, but it definitely is the case that things end up being a little bit more nuanced. One of the three cones picks up on redness, and if that cone is a little bit more tuned to, like 702 nanometers as opposed to 700, that influences what we see as red. Because while it is the case that we have three different types of cones, and various different wavelengths of light will activate some of those more than others, it's not the case that there's this nice one-to-one correspondence with what we see as primary colors and those particular cones. And like, for example, the cone that picks up on the longest wavelengths, so the ones that are more in the red direction, we'll call that L. The other one we call M for like medium range. And then the one that picks up on the bluish ones we call S. If you look at the curves for the L and the M, as in which frequencies of light or which wavelengths of light will activate those cones the most, the ones for L and M are like very similar to each other. It's not nicely separated where M is just peaked out right over the green portion and L is peaked out right over the red portion. In fact, the colors which maximize that longest wavelength cone are the orangish greenish ones that I would not at all describe as primary. So clearly there's some sort of like processing that happens up at a higher level in the cortical hierarchy here, going from just what is the raw data that you're that your eyes are picking up on, up until we actually get to the point of subjective experience, where it like there already is some notion of mixing and matching these, right? Like when we perceive pure red, it is already a mixing of uh, activations from two different types of cones. So I think what becomes interesting is what determines which mixing of those corresponds to what we think of as a subjectively pure color, like red, right? And is it the case that is like mainly biologically rooted, right? Is it the case that in the same way that there are these sort of well-defined curves over what activates a given cone, there's also just a well-defined sort of deterministic process for how those relative proportions are going to get mixed together on their way up into a subjective experience? Or is that something learned over time, right? Where based on what objects we tend to see next to each other or in contrast with each other as we are, newborns beginning to observe the world, does that slowly start to shape, which synapses have the strongest connections versus which ones have no reason to form as well, right?
I guess at the root, there's like 3 degrees of freedom here still. And you can still mix, but you can still mix other colors. So for example, if you see yellow on a computer screen, there is nothing that is emitting any light in the yellow wavelength. You're seeing a mixture of red and green.
That would be appropriate, yeah.
Yeah, red and green. Right. So you're seeing a red pixel and a green pixel lighting up, and so you're getting these 2 different wavelengths hitting you.
Mm-hmm.
And you're perceiving that as yellow because I guess it's sort of tricking the various receptors in your eyes into feeling the same level of activation that they would feel if they were receiving a monochromatic yellow light. You don't have the equipment in your eye to distinguish those 2 things, whether you're seeing a monochromatic yellow light or whether you're seeing a mixture of red and green light.
So you're saying that particular like mixture of red and greenness was always destined to be one that sort of stood out as special because that is exactly the same mixture of activations that would happen when pure monochromatic yellow is hitting the eye.
Yeah, I don't know that I would call it special in any respect. I mean, but it would be the same as the pure monochromatic yellow, and you wouldn't be able to distinguish it, and presumably neither would anyone else unless someone had a dramatically different distribution of how their various cones picked up on things.
That gives a really good example of a balance between activations of the red, or I shouldn't even say of the red, of like the long cone and the medium cone, like how a certain balance of those ends up corresponding to something that seems pure to us, where it's because like yellow light is a phenomenon in the world, and like that gives, I don't know.
But I guess what I'm saying is like you could have different wavelengths and different combinations of wavelengths entering your eye, and they would be indistinguishable. So for example, if you have this yellow light coming in, maybe it activates your red cone, I guess that's the L cone, a little bit, and it activates the M cone a little bit, and maybe it even activates the S cone a very tiny amount because it's a curve that has some overlap over there. And so your brain puts all that together and says, that's yellow, or that's what I'm used to calling yellow. But then you could have a different wavelength of light that only activates the L cone, combined with a different, a second wavelength of light that only activates the M cone, combined with a third wavelength of light that only activates the S cone. And then you can set the levels of those 3 different lights to activate the cones in the exact same intensity that they would be activated by just this yellow light. And you would have no way of distinguishing that.
Yeah, I hear what you're saying on how different physical phenomena can give the same biological response. I guess what is the point?
I guess the point is that there is information in that light, or there's a significantly more information in that light or in that color or whatever you want to call it, or that combination of light that's entering your eye, than you are physically able to determine.
Yeah.
But perhaps if your cones were tuned slightly differently, then you would be able to make those distinctions in a way that a different person wouldn't be able to.
Oh, yeah. Like if you had some creature that instead of having 3 cones had 5 cones, whose curves were situated appropriately, they might look at a computer screen yellow and look at it and say, "What the hell are you talking about? That's not yellow. That's like clearly that's reddish green. A very, very different thing." So what you're saying is, if you have 2 different humans who disagree on the color of the dress or the color of a tennis ball or something like that, like you're saying subtle adjustments in their cones or what specific frequencies are going to activate them in certain ways. Very subtle distinctions there can correspond to widely different subjective experiences in just the same way that like.
Well, I'm saying a couple things. Yeah, I guess I'm saying that might have some impact. I don't really know. But I'm also saying that this idea that because your language has different words for different colors, that you perceive them dramatically different than a different person. Like I'm suspicious of that, because it seems like your eye is kind of set up to perceive a certain set of colors.
I am as well, but in order to be able to say that with confidence, I would need to feel like there's a really good reason why. Like, I used to think that there was a good reason why we sort of divide the rainbow naturally into these 6 colors, right? It's that we have 3 cones, and each individual cone might pick up on one of the pure primary colors. Like, one of them picks up on blue, one on green, one on red. And then when a pair of them is going off in a certain proportion, that we have a subjective experience associated with that. So when, like, green and red are going off in a pair, if we see that as yellow, that, so it's like each one of the 3, then each pair of them. And then that's just not at all true. That's not at all what correspond to these colors. So then that sort of circles back to like, why 6, right? Why is it not the case that we naturally divide it into 7? And it's not so inconceivable to me that if you imagine having a child and then putting up like labels through their room as they're growing up, where you have all the colors of the rainbow nicely gradienting through from violet to red, but you just happen to chop it up differently, right? And if you chopped it up in such a way where you just made up a new name for one of them in the middle there, whereas you go from like what is a dark blue to what is a light blue or whatever it might be, you're just treating them as differently as you would treat red and green. Maybe that does end up training a sensitivity to a specific type of combination that we otherwise naturally wouldn't train a sensitivity to.
Yeah, I guess, I don't know. To me, I see the spectrum as a spectrum, I guess. I don't know that I see it chopped up in the way that you're imagining. I mean, even things like, blue, indigo, violet, I don't know.
Well, the indigo, I feel like indigo was purely something that Newton made up as having more prominence than it should have, just so that there was a nice parallel between how many musical notes there were and how many pure colors there were.
Well, and also when I think of violet, I'm imagining purple, which is not a color, or not a primary color, not a. What am I trying to say? You can't get purple with a single wavelength. You've got to mix blue and red.
In the same way that like pink is not a pure color.
Right. These aren't colors on the spectrum. They're mixtures of colors on the spectrum. And so there's just even the idea that the spectrum includes anything purple, which I guess violet. I don't know. What is violet?
That would be an example, though, of what taught you to think of purple as being kind of some sort of pure color, the sort of thing that if you're going to have only 6 crayons, it deserves to be one of them. Whereas the deep blue that actually corresponds to a pure wavelength is not what you would consider like Crayola worthy.
I don't know, because there are grapes in nature and they're delicious.
Right. It's like it's something learned. It's something. All I'm trying to say, if we think back to the dress or tennis balls or whatever else it might be, and I actually don't think there's any disagreement here, is that you can probably trace the distinctions that people have to some specific set of experiences, color-oriented experiences that strengthen certain connections between color recepting cells versus ones that don't strengthen those connections in the same way.
Well, I wasn't being completely facetious when I was saying grapes are delicious. I mean, that might actually be why purple stands out is that, we evolved color perception so that we could, identify the delicious fruit that was full of life-sustaining sugar.
So some of the inbuilt priors in the brain before any learning takes place, the things that would prime you to learn one thing but not another, were sort of specially tuned to the various combinations that correspond to the delicious grape purple.
Perhaps. And blueberries and oranges and apples. And
we all just agree that it's absurd. We call them blueberries.
What are they? Indigo berries?
Yeah,
violet
they're
berries?
violet berries. They're violet berries, and it's yellow juice. It's not orange juice.
So can we underline the slight controversy we have here? Grant, you seem to be taking a pretty strong stance that our perceptions you think are pretty environmentally driven and based on our experiences. I think my gut is that it's more genetic, that you would explain the variance across human beings and how they perceive different things like the dress to be much more genetic than you could trace it to a set of experiences. Is that a fair summary? And if so, I want to get Eater's take.
I don't. I guess I'm taking a much weaker stance than that, which is just that seems possible to me. I'm coming out of this like I don't know what to believe anymore. I thought I knew how colors work.
It seems so. It seems possible, but had I like my prior is that is the underdog.
I don't know. I just feel like you know what I really want. I want, and this would not pass by like any ethics board by any means. But once virtual reality is there, and we have all of these questions about is something based on your experience or not based on your experience, right? Like our inability to understand 4 dimensions or, our division of the rainbow into the way that it is. I want to be able to do experiments where you take someone right after they're born, you just put them into this virtual reality environment where rather than the dominant features around being like grape purple, or you're in a 3-dimensional space or things like this, just let them learn about the world in the way that a 0 to 5-year-old does in just a totally different place and actually see how much of it could be contradict whatever priors might have been baked into the brain by genes.
Yeah, that's going to be a struggle to get by the ethics boards.
So one related question, it's my last question, I think. This sort of scientific inquiry along the direct science related to the dress, and then this sort of your crazy experiment, Grant, but you could imagine less crazy experiments. Do you guys see some sort of direct benefit from that? Or is it just kind of this generally interesting thing, and if human beings explore things they don't know, it becomes useful at some point?
That's a good question. Because it's so tempting to say that the answer is no, that there's no direct benefit.
There's certainly benefit to understanding how humans perceive color. If you're doing any work in design, there's just a wealth of knowledge built up in that field.
So maybe that's a bad question. So it's useful. Who is it the most useful to? Who's the guy or girl out there that would just be clamming for this study as it comes out, and it would directly affect their bottom line or quality of life or something?
I think design is a really good one to bring up. Maybe I'm just anchoring on that a bit hard, but I've definitely have in the past had videos where there was a way I was using color to communicate meaningful information, and then the choice of colors could not have been worse given common types of color blindness out there, right? And arguably a better understanding of the, which area, and like which areas are people prone to disagree about things or prone to perceive things differently. I could see that as being useful, right? Like I'm gonna steer clear of pulling up something that could have the same ambiguity as the dress, right? And be like, if you'll notice on the blue and black equations on the left here, in contrast to the yellow and gold ones on the right, like that's the sort of, maybe that's a dumb pathological example, but the same sort of thing where you want to be sensitive to where different people will simply be interpreting a different thing. And most commonly that will be because of color blindness, right? Of like something very starkly biologically different. But I don't know, maybe there's room for things that are less stark, but nevertheless draw lines between society in this way.
But even when you get to color blindness, you're talking, that's a biological defect, right? There's some particular flavor of cone that isn't present in the appropriate quantity. I think one of the most common is sort of the red-green color blindness, where one of those, I don't know which cone, is less prevalent. And yeah, I've run into the same thing where it's sort of interesting. There's a particular shade of blue and a particular shade of pink, which are, to me, very different colors that apparently look quite similar to people with the most common form of color blindness.
Interesting.
And these were colors that we were using actually on Khan Academy for a number of years until I came to this conclusion.
Oh, really?
Yeah.
Is that when we changed? Is that when the color got changed?
That is when the color got changed.
You were the start. You're the start of that?
No, I wouldn't say that. Although I would say that I think before we changed the color for as long as I was working on content there, I was always careful to never use color in a way that was necessary to do the problem. It was always sort of like the color's there to help you, But if you can't see the color, then you're not losing anything critical. So the fact that there was this like huge ambiguity between two of these common colors that we used was maybe less catastrophic as it could have been.
This brings up kind of an interesting design question, I think. Would you say that you should never, in putting out expository material, leverage color to a point where it is something that kind of the explanation is resting on it?
I don't know. So my philosophy when I was making content at Khan Academy, and this is sort of in the early days, so that it kind of set the trend for how things are done there, was essentially what I just said. Use color in a way that if you can see it, it helps, but that all of the information is there if you can't see the color. So it's never necessary. But I never felt like I should hold back of like if I can make this even clearer by adding color, then I would.
Like what makes me think of this, so recently we put out a video entitled like how to solve 2D equations using color. And it was, one of the central constructs in there is this thing called a domain coloring, where in order to understand a function that has 2D inputs and 2D outputs, which you certainly can't graph because that would require 4 dimensions. So you kind of think, how can we try to understand this thing, preferably on a flat screen, not even having to go up into 3 dimensions. And one really nice way to get a feel for it, especially if you only care about the direction of the output, is to color the plane in such a way where, each point in the input kind of corresponds to where on the color wheel it'll fall in the output space. And we sort of illustrate what's going on with that and everything. And it's almost like it's leveraging a different dimension that we humans have available to us. It's not just left, down, up, right, but it is also the red, orange, yellow, green, blue, violet dimension. And being able to use that to communicate like what this function is actually quite useful, at least at a conceptual level. I mean, it's not the case that you're going to like solve an algebra problem because you could see this. But if you can instead describe a general concept of like, if you're moving through the color wheel this way versus moving through it that way, what conclusions do you draw? And we tried when possible not to make it solely rely on the color, right? There was a little arrow to also kind of indicate that direction loosely. And even then it's like bright, vibrant color. So I think something like red-green color blindness maybe wouldn't suffer as much. But if you imagine a hypothetical of someone who actually couldn't see any color, it was just grayscale, I would say that video would be understandable, but it would not be a great experience. You'd probably actually feel a little bit left out more than anything, or the fact that it is leveraging this dimension that most people have available to them, but others don't. But here's a general question: like, would you see that as a reason to steer away from constructs which don't just leverage, but kind of lean on that extra dimension?
So let me ask. I guess I would have explored, although as I'm thinking this through, maybe there's a reason not to, but I would have maybe explored using different brightnesses. Would that have been possible or not, because you need something circular?
Yeah, like in this case, circularity is key. You need something that is changing as you go from facing to the right to facing up to facing to the left to facing down, then to facing right again.
Yeah. So in a lot of visualizations, I think people overuse color. I think one example is sort of like a green to red spectrum to indicate, some quantity or something. Like red is like not a lot of the quantity and green is like if there's a lot of it. And in almost all of those cases, if you're making some visualization, you can convey the same information with just different brightnesses of a single color, which also lets you save color to indicate something else. But yeah, the circularity, I think, is what would cause a problem there.
There was one example, like the one I was referencing for where I made a poor choice, where I think it would not have worked to just use grayscale, where like choosing some colors did matter, where as the video did on neural networks, and we were talking about detecting handwritten digits, right? And the thing that the neural network is supposed to take in as its input is this little 28 by 28 pixel array that is in grayscale. So you think of all of these numbers as in grayscale. And then at some point I wanted to describe doing sort of a weighted sum over all of those pixels, and to think about sort of overlaying a different pixel array with those weights on top of the handwritten image of a 3 or whatever else it might be. And just to show a qualitative difference between the fact that the weight matrix is a different type of thing than the input. Like it could not have used grayscale from black to white because that sort of was already occupied in the pedagogical trajectory. So it sort of had to be some other thing that went from like negative to positive.
But you could do it with a monochromatic other color.
I guess that's true. That's true. I mean, actually, it was worth emphasizing that it could go from negative to positive, right? That you could have like strong negative, weak positive, strong positive, especially to show the contrast between that and that the type of inputs really were just between 0 and 1. They were not arbitrary numbers, any as strong negative as you want, any as strong positive as you want.
And it was sort of, what was 0? Was 0 like black or white or?
Black, I think, in that case.
Oh, okay. So then you were using two colors. You weren't using a spectrum of red through green with a bunch of yellow and orange and stuff in the middle.
Right. I mean, yeah, and the fact that I chose red and green was, I think, a poor choice, but it was like strong red and then like dark red and then dark green, strong green. These are the sorts of cases in thinking about like data visualization or like math visualization where it's like there's fundamentally a lot of information that you want to convey, right? Like a function from 2D to 2D. There's just 4 dimensions worth of information that you want to get down there on the screen. Or in thinking about like the neural network, you've got this 2-dimensional grid of inputs, and then you want another 2-dimensional grid of things. So it's like, again, this sort of 4 dimensions of stuff that you want to try to like put on there. And that's the really interesting territory, I think, when it comes to contemplating how okay is it to lean on color, where like if it's the case that you've really just run out of other options for what human senses you might be able to pull in to think multidimensionally like this. I don't know, my own disposition, and maybe it's like not a great one to have, is that try to do what will be clearest to the majority of people and don't make it inaccessible to those who, let's say there's like a form of color blindness, but like don't let the potential risk of that subset of the population feeling excluded limit you from doing what would be like the best possible visualization for the majority of people.
Yeah, I mean, it's definitely a trade-off. I mean, I'm just sort of imagining like, what if 3 blue, 1 brown, you decided everything we're going to make has to be accessible to blind people.
Right. Like,
I mean, I don't know how you would do that. So much of what you do is visual.
Yeah, that's a perfect example, actually. Yeah, where like the limiting case of accessibility would be kind of an unfortunate non-existence. But at the same time, this it's probably, those are the rarer circumstances. Like 9 times out of 10, when something is done that runs the risk of making someone who is sight impaired feel excluded, it was just done needlessly. Like the blue-pink thing that you're bringing up is a really good example, because that's worth being cognizant of and sensitive to, and otherwise is extremely counterintuitive.
Yeah, it's counterintuitive to me, yet completely avoidable.
Right.
And, we would have lost nothing. And in fact, we did change our colors in part because of that.
Color,
man.
Can't live with it.
Wonder why color was evolved. That's a whole other question.
Oh no, I think it was so you could pick the fruit out of the trees.
Seems like it's an advantage for all sorts of things, right? Fruit being one of them.
Right. That is not accomplished grayscale. Well, it feels like there should only be like 2 dimensions of things that are needed, where you understand if it's dark or bright, like what's the intensity of the light, and then understand what the wavelength is. Is it low wavelength, high wavelength, right? And the fact that there's so many just distinct, like subjectively distinct things on their way in between almost feels like over-engineering.
Well, I don't know that evolution is trying to do that. I mean, it's like, does it give you an advantage? And so if you develop some mutation that gives you a third cone, presumably whenever that happened, it was an advantage to whatever creature got that third cone. And so it survived, and the 2-cone creatures, well, I guess they still survive too, right? Dogs have 2 cones.
Yeah, right. I mean, there's creatures with 1 cone. I think a lot of marine mammals just have what's called like monochromatic vision. Australian sea lions fall into that category, as opposed to, do you know who has a lot of cones? Pigeons.
Pigeons
Have 5 freaking cones.
What?
According to some table, which I totally don't believe at all. If you have 1 cone, the approximate number of colors you can perceive, the point where you say like this is actually distinct from that as you slowly change them, you can discern about 100 colors. If you have 2 cones, you can discern about 10,000 colors. If you have 3 cones, like we do, you might think, oh, it went from 100 to 10,000, so the next step is 1 million. Well, it's actually 10 million, according to this chart that I don't believe.
Huh.
But it's on Wikipedia, therefore there's some half legitimacy to it. If you have 4 cones, 100 million different colors, the Crayola company could just be raking it in. And if you have 5 cones, 10 billion colors. But the reason I'm skeptical about this is because of a recent Radiolab that was describing This very famous animal at this point. You heard this one?
Yeah.
Yeah, like the creature with the most cones. It's got like 20 cones, right? So you see this progression as you go from 1 to 5. Like 1 was 100, up to 5 was 10 billion. This creature with 20 cones is just one of the worst at actually distinguishing colors. So there's clearly something beyond just the cones that has to actually take place to make you sensitive to these things.
What is this creature with 20 cones?
It's a mantis shrimp. Have you not heard of the mantis shrimp?
No.
Okay. You will, it'll take very little Googling for you to find many different people describing this animal in pretty hilarious ways, ranging from like Zay Frank to the oatmeal to Radiolab. One of the fun things about it is the fact that it has 20 different cones. So the initial speculation would be that, when it looks at a rainbow, it's just this crazy onslaught of different subjective experiences, which we've since revisited. But then there's other fun things like its method of hunting and eating is to punch its prey to death with this really fast punch that actually causes these little sonic boom waves inside the water. So just a weird animal, the kind of thing you only ever find in the sea. All right, we wrap it up? You want to make any more connections to IQ?
That's all I got. I almost regret that one. I don't want to double down on that.
I do want to know now if there is that correlation between people who spend more time indoors or outdoors and whatever we're describing as higher level thought.
So, and yeah, there's one, just for the record. There's like activity in regions of brain connected to higher order thinking is potentially linked to intelligence, but very potentially not at all.
Yeah, well, that just like, how are we defining intelligence?
Yeah, we're gonna get lost on that. We got to cut before we dive into that.
Let me see what camp I'm in now. Hang on. Yeah, it's still blue.